In this problem, we're going to prove that this set is a linearly independent set on R. So the way we're going to do this is by using Wronskian. So if you recall that the Wronskian is defined to be, let's say for two functions, f and g, it's going to be equal to this determinant. So this is f, this is the derivative of f, g, this is derivative of g. This is equal to f times g prime minus g times f prime. And if this is non-zero, then we can say that f and g are linearly independent. So that's what we're going to be using for this problem. So let's go ahead and prove this. So we're going to call this one our f and this one our g. So here's how the proof is going to be. So let's define this function. Let f be equal to e to the 2t and g to be equal to e to the negative 3 t over 2. And let's go ahead and compute the Wronskian and see if it's equal to 0 or not. So we're going to go ahead and set up the Wronskian. So the Wronskian of these two functions, f and g, is going to be, so the first column we're going to write f, which is e to the 2t. The second column is its derivative. So that's 2e to the 2t. And then the next column, we're going to write g, which is e to the negative 3/2 t. And this would be the derivative, so that's negative 3/2 e to the negative 3/2 t. So that's how you set up this determinant. And now we're going to go ahead and multiply this with that, so this way. And then we're going to subtract away the product of these guys. So that's how you multiply this matrix. So this is going to be equal to negative 3/2 e to the negative 3/2 t times e to the 2t. I'll combine their exponents in a little bit, minus now the one that I drew in purple in diagonal. So that would be 2 e to the 2t times e to the negative 3/2 t. So that's how you perform this multiplication. And now we go ahead and combine like terms. So here I can add these exponents, and we can also add these exponents and realize they both have same exponents. So that makes it easier. So this is a negative 3/2. So when you do negative 3/2 plus 2, and they both have t, so just ignore that for now, you put them in common denominators, so you'll get 1/2. So the exponents for e would be 1/2 t. And similarly, this is also 2e to the 1/2 t. And now we're going to go ahead and combine these coefficients, because negative 3/2 minus 2, so that will be a negative 7/2 e to the 1/2 t. So a lot of algebra as you're working through this problem you'll encounter. And now, well, this is not equal to 0. And so we conclude that this pair is linearly independent set. So since the Wronskian of these two functions is non-zero, we can say that f and g are linearly independent on the entire real line.